Greetings, welcome to the 14th lesson in a series of lessons on basics of power systems engineering. In a previous lesson, I covered the Y to delta and delta to Y conversions in resistive networks. The current lesson extends the coverage of these conversions to impedance networks. The configuration of the three impedances on the right is called the Y configuration, and the one on the left is called a delta configuration. The idea is, given one configuration, to find the elements of the other so that they are equivalent from the point of view of the 3 points A, B, and C of the circuit to which they belong. Once that calculation is done, either one of these configurations can be replaced with the other without affecting the external circuit to which they are connected. Let's take a look at the conversion of Y to delta first. Given the impedances ZAO, ZBO, and ZCO of the Y configuration, the impedance of ZAB of the delta configuration can be calculated as this equation here. Let's take a quick look at this. ZAB equals ZAO plus ZBO plus the product of the two, ZAO times ZBO, divided by the third impedance. To see the conversion better, I have coincided the two configurations in the next slide. So once again, looking at this formula, ZAB equals the sum of the two impedances from the Y configuration, the two impedances that are next to it, ZAB plus ZBO, plus the product of the two divided by the third impedance. Although I'm not showing it here, but the other two delta impedances are found using a similar equation. Let me write that out. So to find ZBC, we look at the two next to it from the Y configuration, ZBO plus ZCO, plus the product of ZBO times ZCO over the third one, which would be ZAO, and ZCA, this one, is going to be again the sum of the two that are next to it, ZAO, ZAO plus ZBO, ZCO, these two, plus their product, ZAO times ZCO, over the third one, which is ZBO. Now let's look at the conversion of delta to Y going in this direction. For this case, I'm going to use the admittance equivalent of each impedance in the delta configuration and calculate the admittances of the equivalent Y elements, which I'll then convert back into impedances. In other words, I'm going to replace ZAB with its inverse, YAB equals 1 over ZAB, and similarly for the other two, YBC and YCA. And instead of calculating these three impedances, I'm going to calculate YAO, YBO, and YCO from those admittances. And then I just have to invert these to find the impedances of the Y configuration that I was looking for. The reason for this approach is that dealing with admittances results in equations that are similar in the structure to those we have seen for Y to delta conversion, and that makes it easier to remember those. Here's the conversion equation for YAO. So YAO equals YAB plus YCA In other words, the sum of the two admittances that are connected to the same point A, plus the product of the two of them, YAB times YCA, over the third admittance, YBC. Again, to see the relationship between the two sides better, I'm going to coincide these two together on top of each other. And you see them on this figure. Again, YAO equals, looking for this one, equals the sum of the two that are next to it, YAB plus YCA, plus the product of the same two divided by the third one. Again, I'm not showing the equations for the other two Y-connected admittances, but they are easy to write using the same structure. Here's a sample of the two conversions side by side. Here I'm calculating ZAB from the delta configuration, and here I'm calculating YAO from the delta configuration, here ZAB from the Y configuration. Let's do a couple of examples, but before starting on the examples, I would like to take a short detour to introduce myself. My name is Fouad Albandi. I'm a PE in Electrical Power Engineering. This is the 14th lesson in a series of lessons on basics of electrical power engineering that I have published on the YouTube. You'll find my name and web and email addresses on this page. You can visit my website where you will find comprehensive modules on topics in power systems engineering. My website address is own-your-destiny.mylearnworlds.com. If you're looking for a resource to review topics in preparation to take the PE exam in electrical power engineering, you will find the modules on my website to be helpful. I will now continue the lesson with the first of two examples. In this example, we're given the resistances of the Y-connected trio of impedances and asked to calculate the elements of the equivalent delta connected set. Starting with the calculation of ZAB, the equation is the one you see here. Substituting for ZAO, ZBO, and ZCO from these values, ZAB equals sum of these two, plus product of the same two impedances over the third one, 4 ohm. And the answer is 5.5 minus J 6.75, which will go here. Next, I'll calculate the ZBC, and this is the equation for it. Substituting again for the values from the Y-connected impedances, the answer comes to 0.9231 minus J 9.615 ohms, and that goes here on the figure. And finally, for ZCA equals ZCO plus ZAO plus the product of the two over ZBO. Again, substituting from these impedances on the right hand side into this equation. Gives us this, which reduces to 5.4 plus J 4.4 ohms, which is the value of ZCA, and I'll write that next to it. In the next example, I'll start with the delta configuration with the same values as you see here, and go ahead and find the values for the Y equivalent of it. The advantage of using the same delta impedances is that we already know what the answers are, so that will check on our calculations. We gotta make sure that we get these values back in going from here to here. So here's example 2. We'll be working with equivalent admittances of the delta component, starting with the equation for YAO, which is, if you look here, is equals YAB plus YCA plus the product of YAB times YCA over YBC. Instead of converting each of the delta impedances into their equivalent admittances, I'll simply substitute in the equation the inverse of each impedance. In other words, for YAB, I'll put 1 over this value. For YCA, 1 over this value. And for YBC, I'll use 1 over this value. And you see those inserted in this equation and shown right here. 1 over 5.5 minus G 6.75 is for that term. 1 over 5.4 plus J 4.4 is for this admittance. And the same two are multiplied by each other, divided by YBC, which would be 1 over this one. Now that shows in the denominator. Once you do this calculation, you should get this number, 0.2309 minus J 0.1538 Siemens, which is the unit for admittance. One more step and we'll have the ZAO. All we have to do now is just find the inverse of this, 1 over this quantity. And that comes to 3 plus J 2 ohms, which goes here. Next, we calculate ZBO. But again, we'll start with YBO, which equals sum of the two admittances from here, YBC plus YAB, plus their product divided by the admittance of the third one. Again, I'll insert the inverses of each of these impedances in the equation. Product divided by the third one being this one. And that will give me YBO, which comes to J.2 Siemens. So this one happens to be a purely imaginary answer. Inverting that would be 1 over J.2, which comes to negative J5, written out here. So that number goes here next to that one as an impedance. And finally, for ZCO, I'll calculate YCO. YCO equals YCA plus YBC. Well, these are Z's, but the inverses of those. Plus the product of the two admittances divided by the third admittance, 1 over ZAB. Those values are inserted. Product over the third one, which in this case would be this one. And that comes to a purely real number this time, 0.2501 Siemens. And inverting that will give me 4 ohms, 1 over 0.25. There's a little bit of rounding error, so actually this number should have been exactly 0.25 Siemens. And its inverse would be 4 ohm, which is what we expected it to be, because remember we had the answers already. With this, we have reached the end of lesson 14. This is Fuad Almandi. I'm the founder and instructor of the online educational group Own Your Destiny. If you enjoy watching my channel, please click on the subscribe button and the notification bell. Thanks for watching this video, and I hope to see you soon in another one of my presentations.